Okay, so today's topic is aldehydes, ketones, and carboxylic acids.
Yes.
तो सबसे पहले आपने ये पढ़ा होगा जैसे CH2 double bond CH CHO. What is the name of this compound?
This is this would be prop 1 enol, prop 2 enol.
Okay. Means common name I am talking about. What is the name of this compound and these two?
The common name, sir.
Yes. So keep in mind this is crotonaldehyde
Okay.
and this is
Cinnamomaldehyde.
cinnamaldehyde, right?
Alright.
Then yes, what is the name of this compound?
Metasalicylic aldehyde.
It is simply salicylaldehyde, right?
Alright.
So if we see the preparation, from alcohol, we can prepare aldehyde by using which reagent is best reagent to use to convert primary alcohol into aldehyde?
PCC.
Yes, primary alcohol can be converted into aldehyde by using PCC, because if we use strong oxidizing agent, they convert it into carboxylic acid. Sorry. What is the product formed?
Product would be propanol.
No. See, PCC. So we have this compound, right? Because
Yes.
PCC cannot affect even double bond. It is a mild oxidizing agent. That's why it is best.
Alright.
Okay.
And so copper is also used, right?
Copper at 573, CrO3. We
Yes.
can
Jones reagent, Sedgwick's reagent.
yes, we can use them like if we have primary alcohol, secondary alcohol.
And so for benzaldehyde and aldehyde, they use ethanol.
Yes. So tertiary alcohol. So if we use copper at 573 Kelvin, in first case we will get, and in the second case we get ketone, and in the third case what will we get?
No reaction.
Oh, it will give ethene. Okay, this is dehydration, rest are dehydrogenation.
Right.
With primary alcohol and secondary alcohol we get aldehyde and ketone, so these are dehydrogenation reaction, but in case of tertiary alcohol we get dehydration reaction. ठीक है? It is called isobutylene.
Yes, I do that.
Now this is from PCC and what is the product formed?
benzyl chloride, sir.
So here we can get benzyl chloride, benzyl chloride,
Or
or, or benzochloride, because it is a, yes, it is a free radical reaction, and this is particularly benzylic chlorination.
yes.
What if we have ethyl benzene? So what is the product form?
It will react with benzyl carboxylic.
Yes, keep in mind it is always benzylic, which is chlorinated first.
Yes, sir.
So in this case, if we hydrolyze it, we get benzyl alcohol. Hydrolyze even in the presence of KOH or even H2O will serve the purpose.
All right.
What about this?
After formation of diol, it will reduce H2O.
Yes, it becomes aldehyde, because two OH cannot be remain as such on the same carbon. Only one OH can be stabilized on like this. If there are two OH, then water is removed. In this case, there are three OH, so we get benzoic acid. So this method can be used to prepare benzyl alcohol, benzaldehyde, or benzoic acid. So if there is controlled chlorination, we get monochlorinated product. And to get benzaldehyde, we prepare benzyl chloride. And if we like to prepare benzoic acid, we replace all the hydrogens by chlorine.
All right.
What is Gatterman-Koch reaction?
Preparation of benzaldehyde, sir.
Yes, benzene is treated with
Dichlorocarbene.
no CO and HCl in the presence of CuCl.
All right.
So CO and HCl, they give CuCl and anhydrous AlCl3. It is just like Friedel-Crafts acylation, but you know, when CO and HCl, they give formyl chloride in C2, because formyl chloride is highly unstable. So we cannot use formyl chloride directly. So what we do, we prepare it in the reaction mixture by using carbon monoxide and HCl. So we get benzaldehyde as the product.
All right.
Then Rosenmund reduction. So in Rosenmund reduction, what we have? We have acid chloride. We treat it with H2 in the presence of palladium and barium sulfate, or sometimes sulfur or quinoline is also used as poison.
Yes.
So partial reduction takes place and we get
Aldehyde.
aldehyde. What is its limitation? Formaldehyde cannot be prepared by this method. This is a method to prepare aldehydes, but formaldehyde cannot be prepared.
Reason being, sir?
Reason is formal chloride is unstable.
Okay, yes.
So we cannot use formaldehyde, a formal chloride, because it is highly unstable. That's why formaldehyde cannot be prepared by this method.
And if we don't use poison, sir, then we get alcohol.
If we use only H2PD, then we get alcohol. Barium sulfate can also, it gives support and at the same time decrease the reactivity of palladium. Stiffen reduction. So in stiffen reduction, what we do? We have alkyl cyanide. We treat it with SnCl2 and HCl. So first of all, SnCl2 and HCl will give nascent hydrogens,
Yes.
and we get imine,
Yes.
which on hydrolysis
Gives amide.
give amide. Now reduction with lithium aluminum hydride and sodium borohydride. So tell me, out of these two, which one is stronger reducing agent and why? LiAlH4. Why is it so?
Because of the bond of air and hydrogen.
Yes, ALH bond is weaker than BH bond. So it give hydride ion easily. So if we have aldehyde or ketone, we can use any one of them. Yes, so we have alcohol, primary alcohol or secondary alcohol. So ketone will give secondary alcohol, aldehyde will give primary alcohol. Sorry. So what are the products formed?
From LiAlH4, okay, from NaBH4 we will get the O will turn to OH.
Okay. Double bond O will give OH because it's ketone, so it gives secondary alcohol.
Yes.
And what about this?
It will stay.
Yes, it remains same. So this is called chemoselectivity of yes. Sodium borohydride is a chemoselective reagent because it will produce mainly aldehydes and ketones. Esters, carboxylic acid cannot be reduced by sodium borohydride. But if we use lithium aluminum hydride, then
O turns to OH and we will get, instead of that we will get CH2OH.
yes, we get CH2OH and CH3OH. So lithium aluminum hydride can reduce aldehyde, ketone, ester, nitrile.
Yes. Also we can also use HI over red phosphorus, right?
Yes, that can be used. Okay, so then come to So if we have this reaction, out of aldehyde and ketone, which one is more reactive and why?
Just a second.
And which type of reaction they will give?
So I think aldehyde is more reactive.
Yes, aldehydes are more reactive than ketones
Due to negative I effect of, due to plus I effect of CH3 group.
due to
Due to inductive effect of CH3 groups of alkyl group.
wait. First reason is steric hindrance.
Yes.
Hindrance due to size. So more the hindrance around CO, because reactive site is CO.
Yes.
So more reactive site is CO, and if it is sterically hindered, the attack will not take place. But at the same time, second is, O negative and carbon positive. So attack takes place on positively charged carbon. So if there are releasing groups on carbonyl carbon, then they will decrease the positive charge.
Yes.
That means electron releasing group and steric hindrance decreases the reactivity towards
Nucleophilic substitution.
nucleophilic addition reaction.
Okay, sir. CO group will give addition.
Yes. So if we have Grignard reagent, R negative, MgX positive.
Yes, so R negative goes to carbon and MgX goes to oxygen.
So it is like this, which on hydrolysis so it is RCH2OH. So we will get primary alcohol. If we have C double bond OH, then obviously this carbon has one R group, O turns into OH, so we get secondary alcohol. And if we have ketone, then so obviously 2 R are already there, 1 R from RMGX, and O turns into OH. So in this way, we will get tertiary alcohol. So primary alcohol, formaldehyde gives primary alcohol.
Yes.
Other aldehydes give secondary alcohol, and ketone will give tertiary alcohol. Then come to carboxylic acid that will react with Grignard reagent in this way. See, this is first they give aldehyde, and aldehyde further react with RMGX.
Okay. Yes,
Even
sir.
ester react But if we have carboxylic acid, we will use 2 moles of RMGX. And if we have ester even, let us say this is RR dash. Okay. We treat it with RMGX, and obviously that you know, I think. Why RMGX is used in dry ether?
Yes, sir, to prevent formation of alkane.
Yes. So it is OMGX, OR dash, R, right? So here it first remove this one. There is a removal of MgX OR dash. So it leads to the formation of ketone. With aldehyde, with any acid derivative. Okay. We get ketone, and then further reaction takes place. Just like the another reaction. Ketone reaction, so we get tertiary alcohol.
So if we react carboxylic acid with 1 mole of Grignard reagent, can we get aldehyde?
It cannot be stopped here. Reason being, because you are not using 1 molecule of ester and 1 molecule of RMGX.
Yes.
Even if it is in the limited amount, it cannot react stop here.
Alright.
Because RMGX present in it, that will react further, and we get ultimately tertiary. We cannot stop up to here in the presence of RMGX.
Yes.
Or we can say this is not the best method to prepare ketone from ester or carboxylic acid. Okay. Then come to let us do aldol condensation, because aldol condensation and Cannizzaro reaction, these are very, very important.
Yes.
So aldol, first of all, we have CO. This CO group attached to saturated carbon containing hydrogen, means alpha hydrogen is required, and this alpha hydrogen is acidic. So this alpha hydrogen is removed as H plus,
Yes.
and we get this ion,
Yes.
but this ion is resonance stabilized,
Yes.
and that's why it is called enolate ion.
Alright.
And this enolate ion acts as a, yes, it acts as a nucleophile. Obviously, attack is from carbon, because negative charge is least stable on carbon, though this form is more stable, because negative charge is more stable on oxygen, and most of the time it is on the oxygen only,
Yes.
but it reacts through this, because this carbon, saturated carbon next to the CO, is more nucleophilic, but this removal of this hydrogen is caused by CO, because it is electron withdrawing group, and therefore it increases the acidic strength of this alpha carbon.
Alright.
And means alpha hydrogen is removed easily because of this CO,
Okay.
because it stabilizes it. It is resonance stabilized because of the CO. So enolate ion is a nucleophile, and this enolate ion react with other molecule of aldehyde So see, if we have CHO, so in the presence of dilute sodium hydroxide, this is the end product. So this end product we can form by simply writing it like this, and these two hydrogens should be alpha. So we get this product.
So two alpha hydrogens are needed.
Yes, and to form end product, we should remove two alpha hydrogens. So tell me, what is the product formed in this case?
So X3 in our
See beta, you should write it like this first. And you should remove two hydrogens from alpha carbon.
okay.
So it should be like this.
Yes.
So it is CH3, CH2, CH, double bond C, CH3, CHO. Okay? And it is called alpha beta unsaturated. Yes, alpha beta unsaturated aldehyde. So always if you want to form end product, you should write one aldehyde or ketone as such, CO on the front, and other aldehyde or ketone keep their alpha hydrogen in the first place, and rest skeleton part like this. Okay, and remove that too. If we go through its mechanism, so first of all we have this aldehyde, remove alpha hydrogen, we get this nucleophile, and keep in mind this is called enolate, right? It will attack here. So we get CH3O negative will get H plus ion.
Yes.
So this is beta hydroxyaldehyde.
All right.
Up to this reaction is called aldol reaction.
Yes.
And if we heat it further, water is removed.
Yes.
This is called aldol condensation. And this is alpha beta unsaturated aldehyde.
So hydrogen goes from alpha and OH goes from beta.
Yes, but see, when this OH is removed from, actually this CO part is removed.
Yes.
So obviously two hydrogen which are removed. See first, see this only. In this alpha hydrogen is removed first.
Yes.
Again this alpha hydrogen is removed.
Yes.
So two alpha hydrogens are removed.
Understood.
And oxygen is removed from keto or aldo. Now if we have different aldehydes or one aldehyde and one ketone,
We get four products.
and because both of them have alpha hydrogens, right?
Yes.
So both have alpha hydrogens, what happened? First of all we have CH3 CH double bond O,
Yes.
and both alpha hydrogens of the same. Then CH3 CH double bond O, alpha hydrogens of the another.
Yes.
Then CH3, CH2, CH double bond O, alpha hydrogens of the same,
Yes.
CH3, CH2, CH double bond O, and alpha hydrogens of the first one. So see, this is simple product.
Yes.
This one is cross product.
Cross reference. Yes.
This one is again simple product. Cross product.
Yes.
So if electrophile of the first and nucleophile of the first are used, then that is we get simple product. If electrophile of the first compound and a nucleophile of the second compound is used, that is called cross product.
Yes.
If electrophile of the second and nucleophile of the second, then simple. If electrophile of the second and electrophile of the first, we get cross product, and this is called cross aldol condensation. So products are, first is CH3, CH double bond, CH, CHO.
Yes.
Second is CH3, CH double bond C, CH3, CHO.
Yes.
CH3, CH2, CH double bond C, CH3, CHO. And fourth one is CH3, CH2, CH double bond CH, CHO. So these are the four products we will get.
Understood.
So if we have benzaldehyde and acetaldehyde, acetophenone. So see, benzaldehyde have no alpha hydrogen.
Yes. So we need two products.
So see, this is, and nucleophile,
Yes.
H2, CH, C double bond O, benzene ring, H2, CH, C double bond O, and this one, but see, this product is least favorable because you don't know this nucleophile is bulky, it is sterically hindered. That's why this product is not formed,
All
or formed in very minimal amount that can be neglected.
okay.
So majorly here there is no need to heat even.
Okay.
Why is it so? Because this is completely conjugated system.
Yes.
See, we will have this, see, conjugation all around. That's why this is the main product formed, or we can say it is the only product formed.
All
Now, Cannizzaro reaction. So in Cannizzaro reaction, it is one type of
disproportionation reaction.
disproportionation reaction, and aldehydes having no alpha hydrogen.
And
See, this has alpha carbon, no alpha carbon, and there is no alpha hydrogen. So, in the presence of concentrated KOH or NaOH, or sometime it is written as 50% NaOH or KOH. So, first it will undergo reduction. So, hydrogen is added both sides of the double bond, and in another case this H is replaced by ONA. Again same cases, one is this C double bond O becomes, means hydrogen is added on both sides.
understood.
COONA. So this is Cannizzaro reaction.
Yes.
CHO group has plus R effect or minus R effect?
DHO group has it. Wait, CHO. It takes electrons from the next cell, so plus R effect.
O minus R.
Oh, minus. Sorry, sorry.
Just keep in mind, if it has pi bond,
Yes.
it has minus R effect, okay?
Yes.
So if it is minus R means it withdraw electrons,
Yes.
and resonance takes place at ortho and para, means it decreases electron density particularly from ortho and para. So if electrophile attack, that will attack definitely at meta position. So we get meta nitro benzaldehyde, because it is meta directing and deactivating. What is the order of acidic strength?
So nitrobenzoic acid will be most acidic.
Yes. Fifth is most acidic, because it has minus I as well as minus R, means it is strongly electron withdrawing in nature.
Yes.
What about chlorine? Yes, so it comes second. Yes, minus I and plus R, and minus I is dominating while deciding reactivity. Okay. What about this?
This has minus I and plus R elements.
Minus I and plus R, and this is
Plus and hyper.
plus I and hyper conjugation. So obviously,
Weakest. Second will be weakest.
yes. So first and then no, third is weakest because resonance is dominating over hyperconjugation even. So fifth, fourth, first, second, and third.
All right.
Yes,
Acidic and acidic.
yes,
First will be strongest acid, then second will be
yes, because it is withdrawing. So what about HVZ reaction?
N will hard than C.
Yes.
It gives alpha carboxylic acid.
Uh, in the presence of
So in the acid halide.
acid,
Acid halide.
uh, carboxylic acid react with there is alpha chlorination, but which reagent we will use?
Forgot.
चलो हिंट देता हूँ, रेड फॉस्फोरस एंड और
Red phosphorus over H.
तो क्लोरो कैसे?
Red phosphorus and Cl2.
Cl2. Okay,
Yes.
so red phosphorus, Cl2 or Br2 we can use.
All right.
तो अभी क्वेश्चन करें.
Sure, sir.
So we can use red phosphorus Cl2 or red phosphorus Br2, है ना? So we get these products. Or because you know red phosphorus and Cl2 or Br3 will give PCl3 or PbR3.
Oh, okay, sir. Same reactions we used for alcohol too.
Hmm. So aldehyde ketones carboxylic acid, wait, aldehyde, one second. Oh. Okay, so we have this compound,
Yes.
uh, benzene ring, COCH3,
Yes.
CH3 and NaOHBr2.
Hoffman bromide degradation.
Whoa, Hofmann bromide degradation is in case of amide.
Right. Yes.
You have ketone
Yes.
and see it has alpha hydrogen. So it is
Okay. Okay. Other compensation.
NaOH and Br2.
Here.
Beta, we get it is haloform reaction. NaOHI2, NaOHCl2, NaOHBr2. If we use with ketone, methyl ketone, see this is methyl ketone.
CCO.
COCH3 group is there.
Yes.
Okay, so NaOHBr2 or NaOBr. If it is written, so we get haloform, right? And here CH3 is there. Now on hydrolysis,
Okay.
this
We will get to carboxylic groups.
benzoic acid, this will remain as such. So X is this one,
All right.
because hydrolysis that will hydrolyze only Br3.
Yes.
So we get CHOH thrice, and CHOH thrice will give us, see, OCBr3 only, right?
Yes.
So here it will give COOH. Then CHBr3 तो एक यहाँ पे अटैच हो गया ना, हाँ, so it gives CONA first, it gives COONA, ठीक है, and hydrolysis it will give COOH,
Yes.
right? So after getting this, we have next is KMNO4.
Will oxidize CH3 groups.
Yes, now it will oxidize CH3 group, and on hydrolysis, first it gives COOK, and then hydrolysis we get COOH.
So we get metallic acid.
Yes, and on reacting with, this is why,
Yes. P2O5 is reducing agent.
no, P2O5 is dehydrating agent.
Okay. We remove water.
Yes, removal of water takes place. So see, we have C double bond OH, C double bond OH, the water is removed. And hydride we will get.
Yes.
So this is the product formed at the end.
Also, sir, ठीक answer दूंगा sir.
Okay. Answer is already given, but anyhow, tell me. Consider the reaction
Yes, sir.
hexanal plus HCN.
Will use cyanohydrin, sir.
Yes. So see, in CH3, CH3, CH2, 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 and C triple bond N. Sorry, hexanal. C double bond OH.
Yes.
Now on treatment with HCl, HCN, it is always in the presence of some base,
Yes, sir.
because HCN is very weak acid.
Yes.
So it is like this. This part remains as such. Let us take it as R. So C, it becomes OH, H and CN. So what is the nature of this carbon?
Chiral.
Yes, it is attached to 4 different groups, so it is chiral.
Chiral.
Now cyclohexanone. This is cyclohexanone.
Yes, sir.
On treatment with HCN,
Again, cyanohydrin.
cyanohydrin. So we get OH on one side and CN on the other side. Not chiral, because on both sides there are similar groups. So it is not at all chiral. This carbon is not chiral. But in case of benzaldehyde, again it is chiral carbon. So P1 and P3, they are chiral.
Other statements can be also checked, sir.
So these reactions involve nucleophilic
Substitution is wrong, sir.
nucleophilic addition. Okay. Cyclohexanone and hexanal. Obviously, aldehydes are more reactive than ketones. So
Yes.
hexanal is more reactive than cyclohexanone, and hexanal is less reactive than wrong. Reactivity order is first aliphatic aldehyde,
Yes.
then ketone, then aromatic aldehyde.
Understood.
Aliphatic aldehyde, aromatic aldehyde, yes, then cyclohexanone. Okay. So this is the order.
Cycle.
Yes.
Yeah, how many questions, sir?
Next.
Achha.
Ozonolysis of the compound X
Okay.
gives P
Ozone.
and formaldehyde. P is in equilibrium with Q, and in Q all the carbon-carbon bond lengths are equal. Okay. See, first of all, when we ozonized it, what will we get?
Just a second, sir. Carry out the
Obviously, ozonolysis, if it is given ozonolysis, take it as reductive ozonolysis, because that is in our syllabus.
Meanings?
Actually, there are two types of ozonolysis: reductive ozonolysis and oxidative ozonolysis.
Always.
So instead of zinc H2O, if we use H2O2, then that is oxidative ozonolysis, and in that case all the aldehydes are converted into carboxylic acid, right? And ketones remains as such. But here, if it is written as only ozonolysis, so by default we consider it as reductive ozonolysis. Zinc H2O, that is in NCRT. So it will attack on double bond. Ozonolysis.
So how many products will be used?
Sorry,
How many different products will we get, sir?
we get two products, but there are two formaldehydes, three formaldehydes and one other keto compound that I let you know. Just see, first of all, if we have double bond, okay, any groups attached R1, R2, R3, R4, okay, and we do the ozonolysis, we will get simply break double bond and attach double bond O. That's it. Okay. And sometime what happened, products of ozonolysis are given.
Yes, sir. We have to predict the reaction.
Yes, so just we remove oxygens and attach carbon-carbon double bond. See, in this case again, what is this? CH2.
Yes.
These are CH2.
So formaldehyde.
Yes, CH2 double bond O. So 3 molecules of formaldehyde. And here double bond O, double bond O, double bond O, right?
But this product on the outlets will be equal.
But one thing keep in mind, see, CO group, saturated carbon, saturated hydrogen. So there is tautomerism.
All right, understood.
Keto-enol tautomerism. And this tautomerism leads to the formation of, see, first double bond OH, double bond OH, double bond OH, enols. And this is more stable,
Yes, sir.
being aromatic. That's why equilibrium shifts here.
Understood.
So ozonolysis of X gives P. So P and formaldehyde. So obviously this is formaldehyde. So this is P.
Yes, sir. What is Q, sir?
And P is in equilibrium with Q. So this is Q.
Oh,
Keto-enol tautomers are in equilibrium with each other.
अच्छा, okay, sir.
Okay. And in this case, carbon-carbon bond lengths are equal. All the carbon-carbon bond lengths. P forms a silver mirror. So it is not possible because it is ketone. See,
What, sir? Now, see, in P, all bond lengths are not equal, sir.
in P,
All bond lengths are also equal carbon-carbon.
right, carbon-carbon bond lengths are equal in this case also, but it is simply written in Q all the carbon-carbon bond lengths are equal. Okay. So in Q as well, carbon-carbon bond, it is not written that in PQ carbon-carbon bond lengths are not equal. Okay. Yes, but it is, see, first P is formed. Okay. So in the first case, mean in the first step, we get this one product only. Carbon-carbon double bond breaks, and we attach double bond O on both sides. So this is the step 1. Then there is tautomerism, and we get Q. Okay. So Q turns blue litmus red. Obviously, these are phenols. So phenol can turn blue litmus red because it is acidic. P forms the silver mirror test wrong, because tolerance resistance test is given by aldehydes and formic acid, right?
Yes. And some alcohols too.
Alcohols will give tolerance resistance test.
Someone written in the lab manual for class 12 was written that some alcohols.
Let me check. I never went through this part. Anyhow, I will check. Okay. Now Q is aromatic. That's true.
Yes.
Then P on reduction with NH2 and KOH, it is 1,3,5 cyclohexane triol wrong, because this is Wolff-Kishner reduction. So we get cyclohexane. If P undergoes this reaction, then we get cyclohexane, right?
Yes.
Okay, so that means Q and this first and third is right.
The last question is called purification, right?
Yes, Wolff-Kishner reduction. Okay. So now next is choose the reaction sequence shown below and product formed therein. So in first case, see, we have in double bond O. So simply, it is not addition of double bond O. What we use? Tell me.
So we use
HgSO4, H2SO4. That is for alkyne.
okay, we use KOH.
KOH is used for alkyl halides. It is double bond, right?
We'll simply use water.
If we use water, I will give you hint. If we have this product, this is alkene, and we use acid hydrolysis, then product formed is this one, because this form more stable carbocation,
Yes.
but OH is on the other side, so it is anti-Markov-Nikov addition of water,
Yes.
and that is used hydroboration oxidation. B2H6
pH.
THF in the presence of, and second part is H2O2 OH negative.
Yes.
So this is hydroboration oxidation reaction.
Yes.
So we get U, then CrO3. Yes. This is the product formed.
Yes.
Now with CH3 Mg, Br and H2O.
It will turn into alcohol, sir, again, with an extra CH3.
This is the product formed. Now
Yes.
remove H2O.
Where will we take the hydrogen from, sir?
So obviously this product is formed
Yes.
because beta elimination takes place. So obviously this part is for more stable alkene. There are three products. Okay, X, Y, and Z. So first this one.
Yes. Second, okay, position of pi mod will be different.
This side.
Third, okay, it will take.
So these are the three products. So most stable is first one,
Yes.
then this one and that. Because here it is more alkylated alkene. According to Sergeff rule, more alkylated alkene is more stable. Okay. So these are the three isomers formed because there are three types of beta hydrogens.
Yes.
1, 2, and 3. So first is acid catalyzed hydration of T provides U. It is wrong because if we do acid catalyzed hydrolysis, we will get this product.
Yes.
Then compound W reacts rapidly with concentrated HCl to give, this is Lucas reagent test because obviously it is tertiary alcohol.
Science for tertiary alcohol gives immediate turbidity.
So it is right. Dehydration of compound W give a mixture of X, Y, and Z in equal quantity. Wrong.
Equal.
X is more than Y, Y is more than Z as per their stability order.
Yes.
Then hydrogenation of compounds X, Y, and Z gives a single compound. So that's true. It is by mistake they have done. So this is right. Maybe sometime options are not correctly written. That's why this is right. Yes, it is, third statement is or are. So obviously second and fourth is right. Okay. One mole of what happened?
What's it?
Uh, 1 mole of toluene we have
2 moles of Cl2 in presence of light, which is X. So X is benzaldehyde, sir.
yes 2 moles of Cl2, right, in the presence of light. So we get CHCl2.
Yes.
that is X, which on hydrolysis
Okay, X is CHCl2.
at 100 degrees Celsius give benzaldehyde. Now Y on reaction with HNO3 and H2SO4. So obviously we have done this, that CHO is meta-directing.
Yes, sir.
So we get the product, meta product,
Yes.
that is Z, as the major product. So compound Z, so obviously it is meta nitro benzaldehyde, right?
Yes, sir.
CH3 CH2 COOH, and it is, yes, it is HBZ reaction. And what we get, we use red phosphorus and Br2, right? Red phosphorus Br2, and then hydrolysis, right? So we get CH3CHBr COOH.
Hydrolysis function?
No, means P and Q is written. Otherwise, we use red phosphorus Br2 and H2 actually to get this product.
All right.
Then next is CH3CHBr and COCl, means we can use PCl3, we can use PCl5, and best chlorinating agent is SOCl2, right? And then this is Rosenmund reduction. Yes, Rosenmund reduction. So H2PD barium sulfate. So that's it. So see, means reactions are from NCRT only, but level of the question is okay. H3O plus heat, H3O plus heat. In both the reactions, there is H3O plus heat, but in first case, there is benzene ring, OCO CH3 double bond, here only the difference is methyl group is attached on one side. CH3COOH removal on hydrolysis. So see, it is like O C double bond O CH3
Yes.
O C double bond O CH3. So when we hydrolyze it, ester hydrolysis, we get alcohol and acid. So this part give acid, CH3COH, CH3COH. See, okay. Then we get enol. This is enol. So tautomerism takes place. So we get keto is the major product.
Yes.
It is CHO, aldehyde is formed. In another case, again this is enol.
Yes. Okay, we'll get.
Methyl ketone.
Yes.
So first is both X and Y on reaction with Lucas reagent give turbid solutions. Actually, they are not ketones, sorry, alcohols. Major product is keto, acetophenone and aldehyde. So this is wrong because they will not give Lucas reagent test.
Yes.
Then second is Y. This one is Y, right? And this is X.
Yes.
Y on reaction with bromine NaOH gives sodium salt of phenylacetic acid. Which reaction is this?
This is no, haloform gel.
Yes, bromoform reaction. We can say haloform reaction. So in this case, what happened? C double bond O remains as such and it gives sodium salt along with CHBr3. So that means sodium salt of phenyl acetic acid. Okay, yes, there is CH2.
Acha, yes.
CH2 and then it is COO and ONA, right? That means it is right.
Yes.
X is aldehyde. So obviously it forms silver mirror. It gives tolerance reagent test. The reaction of Y with NH2 followed by heating with KOH in ethyl gives normal propyl benzene.
Wolff-Kishner reduction.
Yes, it is Wolff-Kishner reduction.
And propyl benzene.
Yes. So benzene
Yes.
1, 2, 3. Obviously 1. This CO becomes CH2. So CH2, CH2, CH3. So we get propyl
Yes.
benzene. Yes. We have aldehyde, aldehyde with no alpha hydrogen, right?
Yes, sir.
There is no alpha hydrogen. So it undergoes
Addition.
OH negative concentrated. Which reaction it undergoes?
Yes, sir. Concern.
Yes, Cannizzaro reaction. So in Cannizzaro reaction, there is one product is formed here. Okay. This is,
Yes.
it remains as such and this becomes O negative. OH negative ion first attack on it. So we get Q.
Yes.
Now this Q will react with, yes, another molecule of the same reagent, and what happened?
It will.
This is the mechanism of Cannizzaro reaction.
Yes.
This is a hydride ion transfer.
All right.
So when this hydride ion transfer takes place, we get C double bond O, OH along with O negative, and these are HH.
Yes, sir.
Then it is in equilibrium, because carboxylic acid is stronger acid than this carbonate, alkoxide ion, and therefore one of the OH group, H plus ion shift to alcohol. So we get these two products. So this is a complete reaction, means mechanism of Cannizzaro reaction, and this is the rate determining step in Cannizzaro reaction. Transfer of hydride ion is okay.
All right.
So first is same mechanism will operate if compound P does not have one of the methyl groups. Wrong. If there is no methyl group here, there should be hydrogen. Then there is
Then we get alcohol.
aldol. That means statement is wrong. Reaction involves both oxidation and reduction. Disproportionation reaction takes place. Equilibrium is favored towards T and W, because T and W are weaker conjugate base and acid as compared to R and S, right? This is stronger acid, so it's weak conjugate base. Means comparatively, if we compare alcohol and carboxylic acid is stronger acid than alcohol. So W is weaker acid, and if we compare the bases R and S, in T negative charge is delocalized,
Yes.
but here negative charge is, means its intensity increases, it is not delocalized. At the same time, this tertiary butyl group increases electron density on this oxygen, and that's why this is stronger base than T. So T and W both are weaker conjugate base and conjugate acid as compared to R and S.
Yes.
Hydride is a nucleophile in the reaction Q with P. That's right, because hydride ion, there is nucleophilic addition takes place, and this is the slow step, and that's why it is called nucleophilic addition reaction, or transfer of hydride ion in Cannizzaro reaction is the slow step. So these three, all the 2, 3, 4 are right statements. Okay? Then actually I have collected so many questions. Oh, okay. Next is X on reaction with sodium borohydride gives Y. If we treat it with sodium borohydride, what will we get?
We will get this group will be reduced to OH.
It becomes CH2OH.
Yes.
This carboxylic group remains as such.
Yes, sir.
Now, which upon treatment with catalytic amount of concentrated sulfuric acid,
Okay, sir.
yes, very good. It is, we can say, same intramolecular esterification. Okay, so OH from one side means H from alcohol and OH from acid. Yes, sometime question may be like this, okay, that this is given and it is O18 and this is simple. So water is, there is a removal of water. So O18 is in water or in ester? So it is in. So keep in mind, whenever esterification takes place, sorry, H is from alcohol, okay. In esterification, H is coming from alcohol and OH is coming from acid.
Yes.
Do you know why? Is it like that? Okay.
Yes, sir. There's a lot of disturbance.
From the start or right now?
Right now, sir.
Okay, wait. Now is it okay? Hello?
Yes, sir.
Okay. Okay. So see, first of all, this alcohol, this O of alcohol will attack here. O from the alcohol will attack at a carboxyl carbon, and it is 1, 2, 3, 4, 5. So there are 5
Yes.
carbons and one position is oxygen, this O and H. This is positive then.
Yes.
And see, let us do the numbering 1, 2, 3, 4, and 5. So OH 1, 2, 3, 4, and fifth position there is O negative and OH. Then this O negative gives CO and OH negative and here H plus. So that's why when product is formed, there is a removal of water. So in water, OH is from the carboxylic acid and H is from alcohol. So we get this product. Compound Z is this one, okay?
Um,
So 2-phenylpropanamide, 2-phenylpropanamide. Is it like this? This is 1 and 2, 2 phenyl propanamide, sorry, propanamide.
Propanamide. So
Okay.
one CH3 group. CH3,
Okay.
CH2, CONH2 पे 2. Yes. So
It is like this, okay. There is CH3. Now with Br2NaOH, it is Hofmann bromide degradation. So this is P. P on reaction with ethanolic anhydride. What is ethanolic anhydride? Ethanoic anhydride.
CH3, C double bond O, O, C double bond O, CH3.
So on,
Acetic anhydride.
so this is acylation reaction.
Yes. CH3.
Yes. So benzene ring CH3 NH CO CH3 along with CH3 C double bond O OH. So which one is the right product? Option A is right. Okay. So that's all. We will continue these reactions only in the next class as well. Okay. Tomorrow in the evening. Okay. Or you need some theory part, or this is okay. I think questions are practicing question is good because that will revise your reactions as well. Hello. Yes. है ना? ठीक है, तो क्वेश्चंस वी विल कंटिन्यू. ठीक है बेटा. Great. So means next question means there is so much uh, means next questions there is so much depth in the questions. Means it is not easy to solve the questions. You will get into it. So we will practice all the next question as well as if time allows, I will continue with JEE advanced question as well of the aldehyde ketone carboxylic acid only, because this chapter is very, very important. Oh, KB? Yes. KVPY questions I have taken. There are next question KVPY questions as well. That IAT say KVPY is discontinued now.
Yes, sir. From last 2 or 3 years.
Okay. Okay then, beta. Bye.
Okay, sir. Please send this PDF to me.
Okay.
Bye.
Bye. Beta. यस बेटा, अपने डाउट बोलो बच्चा. यस, जो डाउट है प्लीज बताओ. यस बेटा, कौन सा डाउट है आपका? एमएससी सेकंड सेम के लिए भी करता हूँ भाई। रमेश बेटा, कोई डाउट है तो बोलो, चलो तो मैं रखता हूँ फिर।